Hello students, good morning. You are welcome in the lecture number 5 of a chapter of Ionic Equilibrium. In the last lecture, we have seen Oswald dilution law for weak acid and for weak base. Then we have seen certain numerical examples based on the Oswald dilution law in order to calculate the dissociation constant. Before that, we have seen the theories of acids and bases, and those theories of acids and bases are important over here in order to study the ionization of water. So let us see how the ionization of water takes place. How ionization of water takes place. We have studied different theories of acids and bases. The most important over here we are taking a reference is Lowry and Bronsted theory. According to Lowry and Bronsted theory, we have seen that acids are the substances which are capable of donating the proton. Bases are the substances which are capable of accepting the proton. So proton donor is acid and proton acceptor is a base. Accordingly, the reaction, important reaction we have studied is a transfer of proton and formation of conjugate acid base pairs. So let us see it once again. If we consider the reaction of HCl with water, HCl acts as acid, water acts as base. There is a transfer of proton from acid to base. So this base accepts proton converted to H3O plus. This is known as hydronium ion. And by loss of proton, by donation of proton, HCl is converted to Cl minus. There we have studied on the right side in between hydronium ion and Cl minus ion, which is donor of proton, H3O plus. Therefore, this is also known as acid. Now this is acceptor of the proton, so this is nothing but the base. Acid 1 and base 1. This base 2 and acid 2 are known as conjugate acid base pairs. One more reaction of water we have studied with ammonia. Whenever this same water react with ammonia, there is transfer of proton from water to the ammonia. Water donates proton, ammonia accepts proton. After accepting proton, NH3 is converted to NH4 plus. And after donation of proton, H2O is converted to OH minus. Since this is proton donor, it is known as acid. Proton acceptor, so it is a base. This is nothing but acid and this is the base. Again, acid 1 and base 1, base 2 and acid 2, these are conjugate acid base pairs. This part is important and already this part we have studied while studying the Lowry and Bronsted theory. From these two reactions, one term we have used for water. What is that term? Water is amphoteric substance. Water is having a dual nature. It is amphoteric because whenever water reacts with acid, it is acting as base. The same water, whenever react with base, it is acting as an acid. Both basic as well as acidic properties are present in the water. Therefore, water is known as an amphoteric substance. So this is the important. Now, this water is base and this water molecule is acid. So let us see one more reaction that is important now. H2O plus H2O. Let this is the acidic one, acidic water molecule, and this is the basic water molecule, because water acts as acid as well as base. It is donating proton, this is accepting proton. By accepting proton, this is converted to H3O plus hydronium ion, and this is converted to OH minus. Therefore, this is acid and this is nothing but the base. Acid 1 and base 1, base 2 and acid 2 are conjugate acid base pairs. Acid 1 base 1, acid 2 base 2 are the conjugate acid base pairs. This is important reaction. One molecule of water acts as acid, other molecule of water acts as base. Transfer of proton from acid to base take place and conjugate acid base pairs are obtained. Conjugate acid base pairs are obtained. To this equilibria, if we apply the law of mass action and if we calculate the equilibrium constant, see what happened. What is the equilibrium constant for this reaction? K equilibrium is concentration of product divided by concentration of the reactant. Which are the two products? Concentration of H3O plus into concentration of OH minus. These are the two products. Concentration of product is taken at the numerator and concentration of reactant is taken at the denominator. So divided by concentration of H2O into concentration of H2O, or this can also be written as concentration of H2O square. So K equilibrium will be equal to concentration of hydronium ion into concentration of hydroxy ion divided by concentration of water square. Now practically, this part is important over here now. Practically, it is observed that this concentration of water almost remain constant. This is remaining constant. Why? Because if we take 10 raised to 7 liters, whenever 10 raised to 7 liters of water is taken, how much water is taken? If we take 10 raised to 7 liters of water, only 1 mole out of 10 raised to 7 liters, only 1 mole of water undergo dissociation. Out of 10 raised to 7 liters, only 1 mole of water is undergoing dissociation. 10 raised to 7 liter means how many liter? See here, 10 means 10 raised to 1. This is 10 raised to 2. This is 10 raised to 3, 4, 5, 6 and 7. See, what is this figure now? In terms of, what is this figure now? This is 1 crore. This is nothing but 1 crore liter. So it means that if we take 1 crore liter of water, if we take 1 crore liter of the water, only 1 mole of water is dissociated. That is, 1 mole means how many milliliter? 18 milliliter. 1 mole of water is nothing but 18 milliliter. Out of 1 crore, just 18 milliliter, that is 1 test tube. 1 test tube of water is undergoing dissociation out of 1 crore liter. Therefore, is there any change practically on concentration of water? No. This concentration of water practically remain constant. It is unchanged. So K equilibrium multiplied by concentration of water square will be equal to concentration of hydronium ion into concentration of hydroxyl ion. And I have explained this is constant. This is also constant. So K equilibrium is constant multiplied by concentration of water square, that is also constant, let that is K dash, is equal to concentration of H3O plus ion into concentration of OH minus ion. Constant into constant, always it is constant. See, 2 into 3, always it is 6. 4 into 3, always it is 12, because both are constant. Similarly, this is constant, this is also constant. Their multiplication is also constant, and that is known as Kw will be equal to concentration of hydronium ion into concentration of OH minus ion. And this Kw is known as a constant, that is ionic product of water constant. It is the ionic product of water constant. Now one more thing important here. One more thing important. See, H3O plus. How many H3O plus ions are formed? Whatever the H3O plus ions are formed, depend on which factor? See, this is water, it is acceptor of H plus. This is water, it is donor of H plus. So whatever the H plus, this is donating. Whatever the H plus, this is donating. Same H plus are accepted by H2O, and same number of H3O plus ions are obtained. You got it? Suppose here 3 H plus ions are obtained. So this will accept 3 H plus ions, and 3 H3O plus ions are also obtained. If this is donating 5 H plus ions, this will accept 5 H plus ions, and how many H3O plus are obtained? 5. Therefore, concentration of H3O plus is equal to concentration of H plus ion. This is ionic product of water. This can also be replaced like this. Kw will be equal to concentration of H plus into concentration of OH minus. This is also known as ionic product of water. This is nothing but the ionic product of water. This is important part in order to find out the acidic or basic strength. Now see here, this is the part what I have told here. If we take 10 raised to 7 liters of the water, means 1 crore liter of the water, only 1 mole of water is dissociated. That is, only 18 ml of the water is dissociated out of 1 crore liter of the water. Therefore, practically this concentration remains constant. It is no change. There is no change in concentration of the water. Almost it is constant. Because 1 crore liter, and out of 1 crore liter, just 1 test tube of water is dissociated. No matter. There is no change practically taking place on concentration of water. So this is constant. And taking on left side, we have studied that equation. This is known as ionic product of water. Further, I have told you, whatever the H3O plus ions are obtained, they are equal to the concentration of H plus ions. Therefore, this is replaced by Kw is equal to H plus into OH minus. This is also known as ionic product of water. Now, we have to find out the value of ionic product of water. We have to find out the magnitude of ionic product of water. This is equation or this is equation. Kw or concentration of H plus ion, which is equal to concentration of H3O plus ion. That is also equal to concentration of OH minus ion. You got it? See, whatever the H plus ion this is giving, same number of H plus ion it is accepting. So, same number of H3O plus ions are obtained, and the remaining part OH minus ion is also same. Therefore, concentration of H plus ion is equal to concentration of H3O plus ion is equal to concentration of OH minus ion. Now consider that data and calculate the concentration. We have to find out the concentration of H plus, concentration of H3O plus, and concentration of OH minus ion. See the concentrations. What is concentration? Concentration is nothing but number of moles divided by total volume. Number of moles divided by total volume is known as concentration. So what are the number of moles of H plus or H3O plus or OH minus? From that data, it is equal to 1 divided by what is the total volume? 10 raised to 7. Therefore, concentration of H plus is equal to concentration of H3O plus, that is equal to concentration of OH minus, and that is equal to 1 into 10 raised to minus 7. 1 inverted, now inverted, taken at the numerator. Therefore, this becomes 1 into 10 raised to minus 7. Substituting that value in this equation or in this equation, we can find out the magnitude of ionic product of water. So, Kw, that is ionic product of water, is equal to concentration of hydronium ion or concentration of H plus ion. How much is it? 1 into 10 raised to minus 7 multiplied by concentration of OH minus ion. That is also equal to same 1 into 10 raised to minus 7. Therefore, Kw is 1 into 10 raised to minus 14. This is known as ionic product of water under standard conditions. So, water is very weak electrolyte. we have studied the two type of electrolytes, strong electrolytes and weak electrolytes. The substances which undergo complete dissociation are known as strong electrolytes, whereas the substances which will undergo incomplete dissociation are known as weak electrolytes. Water is undergoing very less degree of dissociation, because just 1 mole out of 10 raised to 7 liters is undergoing dissociation. Therefore, water is very weak electrolyte, and for that weak electrolyte we can calculate the ionic product of water. Kw will be equal to 1 into 10 raised to minus 14. This is about the ionic product of water, and this is useful for classifying the solutions as acids, bases and neutral solutions. Now see here, on the basis of ionic product of water, how these solutions are classified. We know in pure water H plus ion concentration is equal to OH minus ion concentration, and since acid is a substance which gives H plus ions, base is a substance which gives OH minus ions. Here equal number of H plus and OH minus ions are present, therefore water is neutral. It is the neutral, neither acidic nor basic. Since in water equal number of H plus and OH minus ions are present, therefore water is known as neutral solution. If we have H plus ion concentration greater than OH minus ion concentration, see definitions. Acids are the substances which gives H plus ions, bases are the substances which gives OH minus ions. So here H plus is greater than OH minus, means what is the nature of this solution? This solution must be acidic solution. And third category, whenever H plus ion concentration, this is first, this is second, this is third, whenever H plus ion concentration is less and OH minus ion concentration is more, it is known as a basic solution. So these are the three type of solutions on the basis of H plus and OH minus ion concentrations. Pure water is neutral. If we take the case of pure water, this is neutral. Why pure water is neutral? Because H plus ion concentration and OH minus ion concentration are same. It is neither acidic nor basic. So on the basis of ionic product of water, H plus is 1 into 10 raised to minus 7, OH minus, that is also 1 into 10 raised to minus 7. Therefore this is a neutral solution. Second type, if we take H plus ion concentration greater than OH minus ion concentration, this is acidic solution. So you tell me, I am writing two conditions over here. For this solution, I am writing H plus 1 into 10 raised to minus 8 and OH minus 1 into 10 raised to minus 6. So here can you tell me whether this H plus is greater than OH minus or less? I have written it is less. This is not a correct condition. In fact, 1 into 10 raised to minus 6, and if this is 1 into 10 raised to minus 8, now here H plus is greater than OH minus ion concentration, and this solution is known as an acidic solution. We may take 1 into 10 raised to minus 5. This will be 1 into 10 raised to minus 9. 1 into 10 raised to minus 4. 1 into 10 raised to minus 10. 10 raised to minus 2. 10 raised to minus 12. 10 raised to minus 1. 10 raised to minus 13. Like that, the solutions in which every time H plus ion concentration is greater than OH minus ion concentration, they are known as acidic solutions. If they are equal, neutral. H plus greater than OH minus, acidic solution. Now, other case, if H plus is less than OH minus, now this is less, means this is 1 into 10 raised to minus 8, this will be 1 into 10 raised to minus 6. This is greater than this one, so it is a basic solution. Bases are the substances which are capable of giving OH minus ions. So, whenever this is base, concentration is greater as compared with H plus, this concentration, and the solution is basic. If we take this as 1 into 10 raised to minus 2, this will be 1 into 10 raised to minus 12. Which one is greater? Whether H plus is greater or OH minus is greater? OH minus. This is greater than this also. So, this solution is also a basic solution. Thus, the solutions in which hydroxyl ion concentration is greater as compared with hydrogen ion concentration are known as basic solutions. In this manner, on the basis of ionic product of water, on the basis of concentration of hydrogen ion or hydronium ion and concentration of hydroxide ion, we can classify the solutions as neutral solutions, acidic solutions and basic solutions. But in order to compare two basic solutions, see here, this is a basic solution, this is also a basic solution. I am writing one more solution, 1 into 10 raised to minus 3, this is 1 into 10 raised to minus 11. This is also basic. We can easily come to know this is acidic and this is basic. But if these are the three solutions given and we have to identify which is more basic, whether this is more basic, this is more basic or this is more basic. If it is necessary to identify the basicity of basic solutions or if it is necessary to identify acidity of the acidic solutions, this concept is extended as a concept of pH and concept of pOH scale. That concept is extended and there we can compare the acids together or we can compare the bases together. See it once again. What is ionic product of water and how the solutions are classified? What is the constant value? We have seen the concentration of pure water always remain constant. Practically almost it remain constant. Equilibrium constant is also constant. So constant into constant, there is a new constant Kw. So this is known as ionic product of water constant. That is the product of molar concentration of hydronium ion and hydroxide ion. Since we know whatever the H plus ions are formed, same hydronium ions are obtained, same OH minus ions are obtained. Therefore, concentration of hydronium ion is equal to concentration of H plus ion. This is replaced by H plus and we get Kw is equal to H plus into OH minus. This is also known as ionic product of water. Practically we have studied from instrumental methods of analysis the concentration of H plus, H2O plus and OH minus can be calculated because just 1 mole out of 10 raised to 7 liters undergoing dissociation. Concentration is nothing but number of moles divided by total volume. 1 mole divided by 10 raised to 7. Therefore, this become 1 into 10 raised to minus 7. Substituting the values for H plus OH minus or H3O plus OH minus, we have calculated the ionic product of water as 1 into 10 raised to minus 14. 1 into 10 raised to minus 14. And based on that, we can classify the solutions as neutral, acidic and basic solutions. Whenever H plus ion concentration is equal to OH minus ion concentration, it is a neutral solution. If H plus is greater than OH minus, it is acidic solution. If H plus is less than OH minus ion concentration, it is a basic solution. So solutions are classified as acidic, basic and neutral on the basis of ionic product of water. But in order to compare two acidic solutions or in order to compare the strength of two basic solutions, the concept given by Sorensen in the year 1909, that is a concept of pH and pOH scale, is applicable. That we will see in the next lecture.